Today we are going to talk about some supplementary limit laws. I'm going to call this switching things around. Well, what do I mean by that? Well, let's think about, we've talked about this a little bit. Let's talk about x, and suppose that x is large and positive. Well, what does that mean about 1 over x? Well, if x is positive, of course, so is 1 over x, but if x is a big number, think 1,000, 1,000,000, 1,000,000,000, 1 over x is going to be very small. So it's still going to be positive, but it's going to be very small. That is to say, very close to 0. On the other hand, switching things around, if we have that x is small and positive, then what we have is that 1 over x is large and positive. So, if x is 1 over 1,000, 1 over x is 1,000. If x is 1 over 1,000,000,000, 1 over x is 1,000,000,000,000, so quite large, right? And as it turns out, we can actually use this to compute some limits. So what this means is we can basically replace x as it becomes large and positive with 1 over x as it becomes small and positive. And similarly, as x is small and positive, we can replace it with 1 over x as x becomes large and staying positive. So that's a big mouthful. What does that all mean? It means that if I have a limit as x goes to infinity of f at x, well, I can replace x, which is becoming large, with 1 over x becoming very small. That is to say, the limit of f of 1 over x as x goes to 0 from the right. Okay? Because basically we're putting the same thing into this function. This is a number getting bigger and bigger, and this is a number getting bigger and bigger, because this is getting very small, so this is also getting very big. Similarly, we also have that the limit as x goes to 0 from the right of f at x is equal to the limit as x goes to infinity of f of 1 over x, because indeed what we're plugging into f in both cases is numbers that are becoming arbitrarily small. So this is the idea. This is sort of a supplementary limit law, sort of another way to use a composition of limits type idea. So now let's do some examples actually computing some limits with these ideas. So first, let's take the limit as x goes to infinity of something that's going to look a little strange, x squared of cos of 1 over x minus 1. So, oh boy, this looks a little complicated, right? Because we have it's a limit at infinity. We know that this is going to infinity in the first place. But we also know that, well, if we just took the limit of this guy here, as x goes to infinity, 1 over x goes to 0, so this would go to 1, so this is 1 minus 1, so we have this bizarre sort of infinity times 0 case in our limit, and that generally is something that's hard to deal with. But let's do an example here. We can use this switching things around technique and turn this unfamiliar limit into a familiar one, and that's the whole idea. So by what we just said, this is the limit as x goes to 0 from the right of, well, 1 over x squared cos of, I'd write 1 over x, but that's hard to see. Note that 1 over x is just x minus 1. But what is this? This is the limit as x goes to 0 of cos x minus 1 all over x squared. But now this is also a complicated limit, but this is one of our special limits that we've talked about before. This is just something that we know to be equal to minus 1/2. So basically, what we have here is, yes, this is still a complicated limit if you've never seen it before, but what this technique allows us to do is just once we have sort of a big menagerie of limits to work with, once we're familiar with a whole bunch of different ideas, we can take some unfamiliar things and turn them into familiar things. So, assuming you know that this limit is minus 1/2, you can compute this limit by switching these things around. Now let me talk. There are so many examples to do with this, and they can get, unfortunately, quite tricky. But because it's tricky is why I want to share this technique, because sometimes it's the only thing that works, or it's the easiest thing that works, rather. But let me just sort of talk about one way that you can sort of take this to sort of switch around, say, limits at infinity and finite limits, or vice versa. So we'll do another limit at infinity, why not? But just a quick little example is the limit as x goes to infinity of 3x squared plus 1 all over x squared plus x plus 1. So yes, we already know how to do this limit. We could just tackle this limit the same way we tackle limits at infinity generally. But let's just note that we have this flexibility to move things around, and every once in a while, and maybe this is when things get a little bit more proof-based, you might want to take a limit and change it into another form to take something sort of in one shape and turn it into a different shape. And let's just talk about how that would look here. Well, we can again use this technique. We could just replace x with 1 over x as x goes to 0 from the right, and how that would look here is that would be this all over this plus this. Okay, and now we have these 1 over x squareds and 1 over x's in the top and bottom. So of course we can multiply the top and bottom by x squared to give us 3 plus x squared all over 1 plus x squared. And, well, this is a very easy limit to compute, because how do you compute this limit? You just literally plug in x is equal to 0. This is a nice continuous function at 0, so let's do that, and we're going to get 3 plus 0 squared all over 1 plus 0 squared, which is 3. So I guess, if you really don't like infinite limits, one thing you can do with this is you can turn infinite limits into finite ones with this technique.